Okay, so let me summarize the double integral trick. Okay, so this works when you have an integral and an integral of some function of one variable times some function of another. So like say I have a double integral over stuff, a to b, c to d maybe, of f of w times g of v dw dv, right? Okay, so if you can actually factor things like this, you can look at it and you can say, okay, so this first integral that I'm doing is w's, right? So what about this v piece? What can I say? Yeah, that thing doesn't depend on w's, right? So I can take that piece and pull it out of that first layer. I can't pull it out of the second layer, right? But I can pull it out of the first. So then I can say this thing is the integral from c to d of g of v times what?
The integral from a to b.
Integral from a to b of
f of w
dw
and
dv. And now I can think to myself, okay, this stuff
is constant.
doesn't depend on dv, so I can take it out. So in the end here I end up with, okay, this is the integral from c to d of g of v dv times the integral from a to b of f of w dw. You guys see that? This only works as long as you can factor, right, your original function that you were integrating into something to do with w's times something to do with v's, right? For instance, I want to be really, really clear that you couldn't do this to. So this doesn't work with something like the double integral of 1 plus vw dw dv.
That's a function of w and v.
You guys see that? This sucker is stuck as w's and v's. I definitely can't do this thing. You guys see that? But we could do something a little bit similar, right? We could break it across addition,
Then separate them into two.
and then we could do the, right? We could separate it into two double integrals. We could do the first one this way and the second one this way, but this one by itself doesn't do that.